Hello there, and welcome to the Sleepy Science Channel. Tonight, we'll look beyond our own galaxy and discover a giant lurking in the night, Andromeda. To the naked eye, it appears like a faint blur in the sky. But in reality, it is a colossal system filled with more than 1 trillion stars. Its arms sweep across hundreds of thousands of light years, glowing softly through the black of space. The light we see began its journey over 2 million years ago, long before the first humans walked the Earth. Every glimmer we catch carries the story of a distant sun, a cloud of dust, or a world no one will ever reach. Inside those vast arms, stars are being born, colliding and fading. Andromeda is not just another point of light. It is our nearest great companion, moving steadily toward us through the void. In billions of years, it will meet the Milky Way and form something entirely new. If you enjoy these calm explorations, you can like, subscribe, or share a thought below. It helps others find their way here too, one sleepy soul at a time. But for now, all you need to do is relax. Allow your breathing to slow and your mind to soften, and let the universe carry you into rest. Let's begin. Andromeda is the closest large galaxy to our own. Among the countless galaxies scattered across the universe, Andromeda stands as the nearest great spiral to the Milky Way. It lies just over 2 million light-years away, a short distance on the scale of the cosmos, yet vast beyond imagination. This closeness gives astronomers a rare chance to study a galaxy similar to our own from the outside, revealing how stars, gas, and dust form and move within its arms. Through powerful telescopes, Andromeda's structure becomes clear. Its glowing disk stretches across the night, with lanes of dust cutting through rivers of starlight that spiral toward its core. Every image offers a glimpse of familiar order shaped on a grander scale. Andromeda acts as a mirror, reflecting what our home galaxy might look like to others far away. Its nearness makes it one of the most examined objects in modern astronomy, a living example of how galaxies grow, interact, and evolve over time. In its light, we see not only a neighbor, but a vision of our own distant future written across the sky. Inside Andromeda's immense spiral lies an estimated 1 trillion suns, each one burning with its own intensity, color, and rhythm. These stars fill every region of the galaxy, from the dense central bulge packed with ancient suns to the sweeping spiral arms that curve outward into the quiet dark. Some are massive, brilliant blue giants that live short, fierce lives before collapsing into supernovae that seed the surrounding space with heavy elements. Others are tiny red dwarfs that burn dimly but steadily, destined to shine for trillions of years to come. Together they create a light so powerful that it can be seen across 2 million light-years of emptiness. This enormous population of stars gives Andromeda both its gravity and its grandeur. If even a small percentage host planets, then the number of worlds within that galaxy would stretch beyond imagination, perhaps containing more potential habitats for life than there are grains of sand on every beach. On Earth, it can be seen with the naked eye from a dark sky. On a clear, moonless night far from the glare of city lights, the Andromeda galaxy reveals itself to anyone patient enough to look. It appears as a small, misty oval in the constellation of Andromeda, a delicate blur that glows softly against the darkness. That faint shimmer is not a trick of vision, but the combined light of over 1 trillion stars. For ancient observers, it was a mystery, a ghostly cloud that seemed neither star nor planet, existing quietly on the edge of awareness. Only with the advent of telescopes did humanity begin to glimpse its true nature, discovering that it was not a cloud at all, but an entire galaxy beyond our own. When you find it with your own eyes, you are seeing light that began its journey millions of years before written history. You are looking across both space and time, connecting with the same glow seen by countless generations before you. It was once thought to be a cloud within our Milky Way. For centuries, astronomers believed that the Andromeda galaxy was a small nebula within our own Milky Way. Early telescopes showed only a faint, hazy patch of light, leading observers to conclude it must be a cloud of gas or dust. In the 17th and 18th centuries, it was known as the Andromeda Nebula, one of many fuzzy objects catalogued by early stargazers. That belief persisted until the 1920s, when Edwin Hubble used the 100-inch telescope at Mount Wilson Observatory to study it more closely. Within the haze, he found a special kind of star known as a Cepheid variable, whose rhythmic brightening and dimming reveals its distance. His calculations showed that Andromeda lay far outside our galaxy, millions of light-years away. The discovery was revolutionary. It proved that the universe was far larger than anyone had imagined, filled with galaxies beyond number. The Andromeda Nebula was reborn as the Andromeda Galaxy, and humanity's understanding of the cosmos changed forever. Its light takes more than 2 million years to reach us. When we look at the Andromeda Galaxy, we are not seeing it as it exists right now, but as it appeared more than 2 million years ago. Every particle of light that reaches our eyes began its journey long before the first humans walked the Earth. That light crossed the cold, silent gulf between galaxies, carrying with it the record of ancient suns. Some of those stars may have already faded, exploded, or transformed into white dwarfs and black holes, yet their glow continues onward, undisturbed. Observing Andromeda is like looking through time itself. The light that now enters our telescopes began its voyage when the ancestors of modern humans were shaping stone tools and watching distant fires on the plains of Africa. Each observation of Andromeda is therefore both a scientific act and a moment of quiet connection to the deep past. Its radiance is a message from history, arriving unchanged across the ages. It is approaching the Milky Way at astonishing speed. Although Andromeda appears still and serene in the night sky, it is actually racing toward us at a speed of more than 200 kilometers every second. Astronomers detected this motion by studying the light emitted from its stars. That light is slightly shifted toward the blue end of the spectrum, revealing that the galaxy is moving closer. This phenomenon, called blue shift, is unusual among galaxies, since most are receding as the universe expands. Andromeda is one of the few heading directly toward us, drawn by the immense pull of gravity between the two great systems. The approach is invisible to our eyes, unfolding slowly across billions of years. Yet, it is relentless. Nothing can halt this cosmic drift, which has already been written into the motion of space itself. In this quiet advance, we can see both the future of our galaxy and the slow choreography of gravity that shapes the universe. Astronomers have already mapped its collision course with us. Using space observatories such as Hubble and Gaia, scientists have measured Andromeda's motion across the sky with remarkable precision. These observations reveal that it is not simply passing by, but is locked on a direct path toward the Milky Way. Computer simulations trace this trajectory far into the future, showing how gravity will stretch both galaxies into luminous tidal streams before they finally merge. The first close encounter will happen roughly 4 billion years from now, followed by a slow, spiraling union that could take billions more to complete. During that time, the night skies of any surviving worlds will be transformed, filled with vast arcs of stars stretching across the horizon. Mapping this collision has given humanity a vision of its far future written in the laws of physics. It is a quiet but certain fate, patiently waiting on the grand timescale of galaxies. When it merges with the Milky Way, a new galaxy will form. The eventual meeting of the Milky Way and the Andromeda galaxy will not be an explosion, but a slow and graceful merging that unfolds across billions of years. Their spiral arms will twist and stretch into long rivers of starlight as gravity pulls them together. Most stars will never collide directly because the space between them is vast, but their paths will shift, weaving new orbits within the growing system. Over time, the two galaxies will combine into a single, enormous elliptical galaxy with a bright, dense core and broad, diffuse edges. From any surviving planet, the sky will be filled with dazzling light as stars from both systems mingle across the heavens. This merging will mark the next chapter in the life of our cosmos, turning two great spirals into one shining whole that will endure long after the Milky Way's original shape is gone. That future galaxy may be called Milkomeda. Astronomers have already named the galaxy that will emerge from the union of the Milky Way and the Andromeda galaxy. They call it Milkomeda, a blend of the two names that captures the shared legacy of both systems. This new galaxy will likely contain several trillion stars and span hundreds of thousands of light years. At its heart, the supermassive black holes from both galaxies will drift together, spiraling inward until they merge in an immense release of energy. Milkomeda will shine as a smooth, rounded galaxy with a brilliant central glow. To any distant observer, it will appear calm and symmetrical, an elegant monument to the forces that built it. Within its light will lie the combined history of two galaxies that once faced each other across the dark. It is a reminder that even in the quiet of space, everything is still in motion and nothing lasts unchanged forever. Its spiral arms stretch across hundreds of thousands of light years. The Andromeda galaxy is one of the largest spiral galaxies ever measured, its disk spanning more than 200,000 light years from edge to edge. The spiral arms that define its beauty wind outward from a bright central bulge, forming vast lanes of stars, gas, and interstellar dust. These arms are not fixed structures, but moving waves of density that ripple through the galaxy like tides. As these waves travel through regions rich in gas, they compress the material, triggering bursts of star formation that light the arms with clusters of young blue stars. Between them lie darker bands of dust that block and scatter light, adding contrast and depth to the structure. Observing these arms through powerful telescopes reveals how matter flows, collapses, and renews itself over immense timescales. The delicate balance of order and chaos within those spirals tells the story of how galaxies remain alive, forever reshaped by the gravity that binds them. The Andromeda galaxy dwarfs our Milky Way in size. When viewed through a telescope, Andromeda's vastness becomes almost difficult to comprehend. Its sprawling disk stretches more than 220,000 light-years from end to end, nearly twice the diameter of our Milky Way. It contains over 1 trillion stars, and its faint halo extends even farther, fading gradually into the intergalactic dark. If our eyes could see the full extent of Andromeda's glow, it would appear several times wider than the moon in our night sky. Its sheer scale reminds us that galaxies are not tidy spirals of light, but sprawling cosmic cities made of countless suns, nebulae, and clouds of invisible matter. Compared to Andromeda, our Milky Way feels like a smaller sibling orbiting within the same family of stars, both galaxies bound by gravity and destined to one day meet in a magnificent cosmic union. Its core glows with the light of billions of ancient suns. At the heart of the Andromeda galaxy lies a glowing, compact region that blazes more brightly than almost anywhere else in its vast disk. The light here is soft and golden, the combined radiance of countless stars that have burned for billions of years. Most of them are older than our Sun, small and steady, their fuel slowly fading. These ancient stars crowd together so densely that in some regions they are only a fraction of a light-year apart. From that crowded hub, light travels for more than 2 million years before reaching us. The core's golden color tells astronomers that it is home to an older stellar population, where the frantic birth of new stars has long since quieted. In a way, Andromeda's heart is a living fossil, a preserved remnant of its earliest days, glowing quietly across the ages. There may be a supermassive black hole at its center. Astronomers studying Andromeda's core have detected stars whipping around an unseen object at astonishing speeds. The only explanation that fits the data is a supermassive black hole, millions of times more massive than our Sun. Its gravity is so intense that even light cannot escape once it crosses the black hole's boundary. Around it, stars dance in tight orbits, creating a gravitational ballet that has been unfolding for billions of years. The space near this black hole is likely filled with swirling disks of hot gas and dust, glowing brightly as they spiral inward. Though invisible to the eye, the black hole's presence can be inferred through the motion of nearby stars and the radiation emitted by its surroundings. It is a silent engine of gravity, shaping the heart of the Andromeda galaxy and influencing the rhythm of everything that orbits within its grasp. Some believe there might be 2 black holes there, locked together. When astronomers examined the very center of Andromeda with high-resolution instruments, they noticed something peculiar. The light did not come from a single bright point, but from 2. This led to the hypothesis that Andromeda might host not 1 but 2 supermassive black holes, orbiting one another in a slow, immense dance. Such a pair would be the relics of a long-ago galactic merger, when 2 ancient galaxies collided and their central black holes began spiraling together. Over cosmic time, they may draw closer, releasing waves of gravitational energy that ripple through space-time itself. Eventually, they could merge into an even larger black hole. If true, this hidden partnership deep in Andromeda's core offers a glimpse of our own galaxy's future, for the Milky Way also harbors a massive black hole that may one day meet its Andromedan counterpart in a bar. Similar cosmic embrace. The galaxy's halo is enormous and invisible to the naked eye. Surrounding the bright spiral disk of Andromeda lies a vast, diffuse halo that stretches far into space. It is invisible to human eyes, composed mostly of thin gas, scattered dust, and dark matter. This halo extends more than 1 million light-years from the galaxy's center, making it several times larger than the visible portion of the galaxy itself. Within this immense envelope float ancient star clusters and streams of stars left behind by long-vanished galaxies. Scientists study the halo through ultraviolet and X-ray observations, tracing faint signatures of atoms excited by distant starlight. Though ethereal, the halo is crucial to Andromeda's structure, acting as both a reservoir of cosmic material and a boundary marking the edge of its influence. It is the galaxy's ghostly aura, unseen yet powerful, blending gradually with the intergalactic medium that fills the space between galaxies. This halo may already be brushing against our own. The Milky Way and Andromeda are separated by more than 2 million light-years of apparent emptiness, yet recent observations suggest that their outer halos overlap. This means the 2 galaxies are already in contact, not through visible stars, but through the tenuous plasma and dark matter that envelop them. It is as if 2 invisible atmospheres have begun to merge long before the galaxies themselves collide. Over time, this contact may grow stronger, exchanging energy and particles across the void. The idea that our galaxy is already touching another, even faintly, reshapes how we imagine the cosmos. It shows that boundaries in space are rarely sharp or distinct. Instead, galaxies blend and influence one another long before the drama of a true collision begins, whispering their presence through faint glows that stretch across millions of light years. The galaxy's disk is warped like a ripple in a pond. When astronomers mapped the stars and gas in Andromeda's disk, they discovered that it is not perfectly flat. Instead, it bends and twists like a wave frozen in motion. The warp is subtle but immense, lifting parts of the disk thousands of light years above and below the central plane. Such distortions often occur when a galaxy has experienced gravitational encounters with others, pulling and bending its structure. The pattern suggests that Andromeda's calm spiral arms hide a more turbulent history. Beneath their graceful shape lies evidence of ancient collisions, gravitational tides, and slow, majestic motion. Even across cosmic distances, we can see the ripple of those past interactions frozen into the stars themselves, a reminder that no galaxy, however serene it appears, is ever truly still in the restless ocean of the Brescian of Tami. Universe. The warp may have been caused by past galactic collisions. Galactic collisions are not violent in the way we might imagine. Stars rarely collide directly, but their collective gravity reshapes entire galaxies. In Andromeda's case, astronomers suspect that its warped disk and faint stellar streams are the lingering scars of such encounters. Long ago, smaller galaxies may have drifted too close, torn apart by Andromeda's stronger gravity. Their remains were absorbed, their stars scattered into great loops and ripples. The galaxy's disk, once flat, began to bend under the gravitational stress, much as a pond's surface ripples after a stone's fall. Over billions of years, those distortions froze into the shape we see today. By studying the pattern of this warp, scientists can reconstruct the history of Andromeda's mergers, tracing the ghostly fingerprints of galaxies that vanished long before life began on Earth. The galaxy has dozens of smaller companion galaxies. Like our own Milky Way, Andromeda does not exist in isolation. It is surrounded by a retinue of smaller galaxies, known as satellite galaxies, that orbit it at various distances. Some are bright and distinct, while others are faint smudges of white barely visible even through powerful telescopes. These companions include dwarf galaxies rich in old stars and star clusters that may once have been independent galaxies themselves. Their orbits are shaped by Andromeda's immense gravitational field, slowly drawing them inward over time. These companions tell astronomers much about how large galaxies grow. Through countless interactions and gradual mergers, Andromeda has gathered them into its gravitational family. The sky around it is therefore not empty but alive with motion, filled with smaller galaxies quietly circling their massive neighbor. Many of those companions are being slowly consumed. As Andromeda's gravity pulls on its smaller satellites, their stars and gas begin to stretch and disperse. Over millions of years, the weaker galaxies lose their shape, forming long tidal streams that spiral into the main body of Andromeda. This process of galactic cannibalism is slow and silent, but it is one of the universe's most common stories. Through it, galaxies grow larger, incorporating the material of their neighbors. Observations have revealed faint arcs and streaks of stars surrounding Andromeda, each one the ghostly remnant of a devoured companion. The light from those streams tells a tale of creation through destruction, of small galaxies sacrificed to build a larger, more complex whole. Even now, somewhere within Andromeda's vast halo, new streams are forming as tiny galaxies surrender to its pull, feeding the endless cycle of cosmic evolution. Some of its stars were born outside and later captured. Not all the stars that now belong to Andromeda were born there. Many began life in smaller galaxies that later merged with it or passed too close to resist its gravitational pull. As these smaller systems disintegrated, their stars were cast into new orbits within Andromeda's halo and disk. Astronomers can identify these foreign-born stars by studying their chemical composition, which carries the signature of their original home. Some are poorer in heavy elements, marking them as ancient wanderers from primitive galaxies. Together, they reveal that Andromeda's growth has been a collective process, shaped by many generations of mergers. Each new addition has brought its own history and its own starlight, weaving a vast galactic tapestry that tells a story not of one origin, but of many threads united across time and space. Streams of stars trail behind as remnants of swallowed galaxies. The outer regions of Andromeda are threaded with long, faint trails of starlight. These stellar streams are the remnants of smaller galaxies torn apart by gravity and absorbed into Andromeda's mass. Some stretch across hundreds of thousands of light years, tracing the exact paths those lost galaxies once followed. By studying their shape and motion, astronomers can reconstruct the timeline of Andromeda's many mergers. Each stream is a fossil record of an event that shaped the galaxy's structure. These streams also help to reveal the presence of dark matter, since their paths curve according to the unseen gravitational landscape around Andromeda. Though faint and fragile, they are among the most beautiful features of the galaxy, glowing softly in the dark, silent witnesses to billions of years of cosmic history. Its structure reveals a history of cosmic cannibalism. The more we study Andromeda, the more evidence we find that it has built itself through countless acts of cosmic consumption. Its halo contains stars of many origins. Its disk is warped and rippled, and its outer regions shimmer with faint debris from galaxies it has devoured. Each sign points to a long evolutionary journey shaped by merger after merger. Astronomers now see Andromeda not as a single entity, but as the accumulated remains of dozens of smaller galaxies. Even its spiral arms may have been reshaped by these encounters. This form of galactic cannibalism is not violent in the human sense, but is part of the slow metabolism of the universe. Galaxies grow by absorbing others, recycling their stars and gas into new generations of light. Andromeda's beauty, therefore, is also a story of transformation through time. The galaxy is surrounded by mysterious dark matter. Only a fraction of Andromeda's mass comes from visible stars and gas. The rest is made of something unseen, something that does not emit or absorb light. Astronomers call it dark matter. Its existence is revealed only through its gravitational influence, which holds the galaxy together and shapes the motion of its stars. Without dark matter, Andromeda's outer regions would fly apart. The idea that most of a galaxy's mass is invisible challenges our understanding of the universe. Dark matter may consist of exotic particles that interact only through gravity, or it may be a sign of deeper laws of physics not yet known. Whatever it is, dark matter surrounds Andromeda like a vast, transparent cocoon, shaping its fate and linking it to every other galaxy across the cosmos through the unseen web of gravity that binds all things. Dark matter outweighs its visible stars by far. When scientists calculate the total mass of Andromeda, they find that its luminous stars and gas account for only a small portion. The rest must be dark matter, outweighing the visible components by perhaps 10 to 1. This invisible substance forms a halo that extends far beyond the spiral arms, influencing how the galaxy spins. Without it, the outer stars would move much more slowly than they do. Instead, their high speeds reveal a massive hidden presence. Dark matter acts as a cosmic scaffold, giving galaxies their structure and stability. Though undetectable directly, its effects are everywhere. In this way, Andromeda is not just a collection of stars, but also a vast gravitational mystery. Its luminous disk floats within an unseen sea of matter, an enduring reminder that most of the universe remains beyond the reach of human sight. The motion of its stars reveals the presence of that unseen mass. When astronomers measure how fast stars move around Andromeda, they discover something astonishing. The outermost stars orbit almost as quickly as those near the center, even though there is far less visible matter to pull on them. This means something unseen must be providing the extra gravity needed to hold the galaxy together. That hidden force is attributed to dark matter. By mapping the rotation speeds at different distances from the core, scientists can trace how this invisible material is distributed throughout the galaxy. The smooth, consistent motion of Andromeda's stars paints a picture of a vast, dark halo surrounding it, extending far beyond the visible spiral. Through careful observation, Andromeda has become one of the best examples in the universe for understanding how dark matter shapes the grand architecture of galaxies. Andromeda has vast regions filled with glowing hydrogen gas. Across Andromeda's spiral arms lie immense clouds of hydrogen, the raw material from which new stars are born. When starlight energizes this gas, it glows faintly in shades of pink and red, forming nebulae that stretch across thousands of light years. These glowing regions mark sites of active star formation. Within them, gravity pulls denser clumps of gas together until they ignite as new suns. Observing these hydrogen clouds allows astronomers to see Andromeda's ongoing life cycle in action. Even in a galaxy so old and vast, creation has not ceased. The light from these nebulae travels for more than 2 million years to reach us, offering a glimpse into Andromeda's present, as it was long ago. The beauty of these glowing clouds reminds us that even in the silent depths of space, new light is always being born. These regions are nurseries where new stars are born. Within Andromeda's great clouds of hydrogen, tiny pockets of gas collapse under their own gravity. As the pressure and temperature rise, nuclear fusion ignites and a star is born. These stellar nurseries are turbulent yet delicate, filled with glowing gas and dark lanes of dust that weave through them like smoke. Many of these newborn stars form in clusters, lighting up their surroundings in shimmering color. Over time, their intense radiation and stellar winds sculpt the gas into intricate shapes, carving out cavities and filaments. Some of these young stars are massive and short-lived, destined to explode as supernova within a few million years. Others will shine steadily for billions. Observing these regions in Andromeda allows astronomers to witness the same process that once created our own sun, a reminder of how the cycle of cosmic birth continues everywhere in the universe. Enormous bubbles of hot gas stretch far above its disk. High above Andromeda's spiral arms, astronomers have detected vast bubbles of hot gas, each tens of thousands of light years across. These immense structures glow in X-ray light, evidence of powerful energy released within the galaxy's core and star-forming regions. They may have formed from waves of supernova explosions or intense bursts of stellar winds that pushed gas outward over millions of years. These bubbles act as a kind of galactic exhale, venting energy and matter into the surrounding halo. Studying them reveals how galaxies regulate their own growth, balancing creation with release. Though invisible in ordinary light, these colossal forms mark Andromeda's dynamic life, breathing heat and motion into the quiet dark. They show that even a galaxy can pulse and change, leaving vast imprints on the space around it. The bubbles may have been created by violent starbursts. Occasionally, Andromeda experiences episodes when star formation surges dramatically. These events, known as starbursts, flood the galaxy with energy. As massive young stars form and die in quick succession, Their winds and explosions combine to drive hot gas outward. The result is the creation of giant bubbles that expand far above and below the galactic plane. These bubbles are the footprints of Andromeda's most energetic moments, each one carrying material back into the galaxy's halo. Over time, this process enriches the surrounding gas with heavy elements forged inside stars, providing the ingredients for future generations of light. The existence of these bubbles shows that galaxies are not static systems, but living ecosystems that breathe, burn, and renew themselves. Andromeda, like all galaxies, carries the memory of these outbursts within the faint structures that surround it. Supernova explosions continually reshape its interstellar milieu. Across the vast expanse of the Andromeda galaxy, individual stars live out their lives quietly for billions of years. Yet every so often, one of them ends in a spectacular collapse, known as a supernova. These titanic explosions release more energy in a single instant than our Sun will emit during its entire lifetime. In Andromeda, thousands of such events have occurred over cosmic time, each one stirring and enriching the galaxy's interstellar medium. The shock waves from these explosions ripple outward, compressing nearby gas clouds and triggering new waves of star formation. Heavy elements like iron, gold, and oxygen, forged in the heart of dying stars, are flung into space, becoming part of future worlds yet to form. Through this ongoing cycle of death and rebirth, Andromeda's structure and composition are continually renewed. Its luminous beauty, visible from millions of light-years away, is built upon this ancient rhythm of cosmic transformation. Its spiral arms sparkle with thousands of young blue stars. When seen in full color through telescopes, Andromeda's spiral arms glimmer with the bright sapphire light of youthful stars. These young suns are massive, hot, and short-lived, burning with fierce intensity before fading into supernova within only a few million years. They form in clusters within vast clouds of hydrogen gas, where gravity pulls matter together until fusion begins. The ultraviolet light they emit floods their surroundings, causing nearby gas to glow and outlining the graceful shape of Andromeda's arms. These blue stars serve as markers of the galaxy's ongoing creativity, the places where it is still forming new light. Though they live fast and die young, they illuminate the paths along which the galaxy continues to evolve. When we observe Andromeda's glowing spiral arms, we are seeing the energy of cosmic youth scattered across the night, each blue point a brief and brilliant moment in an ancient story. Its center is filled with older yellow and red stars. At the heart of the Andromeda galaxy lies a contrasting world from its radiant spiral arms. Here, the stars are older, cooler, and burn with soft hues of gold and red. These ancient suns have long since exhausted much of their hydrogen fuel and now shine more gently, their light steady but subdued. Together, they create the warm amber glow that dominates Andromeda's central bulge. Over billions of years, star formation has slowed in this region, leaving behind a dense, stable population that moves in complex orbits around the galaxy's hidden black hole. Studying this central cluster gives astronomers clues to Andromeda's earliest history, showing what remains after the storms of star birth have passed. The contrast between the brilliant blue arms and the golden heart tells a story of time itself, revealing how galaxies mature, age, and settle into quiet luminosity as their energy gradually softens with age. Star formation is not uniform across its disk. Although Andromeda's spiral structure may appear symmetrical, star formation within it occurs unevenly. Some regions blaze with clusters of newly born stars, while others are comparatively dark and quiescent. This variation is shaped by the distribution of gas, dust, and magnetic fields across the galaxy's disk. In areas where cold hydrogen is abundant, gravity can easily trigger new bursts of star birth. Elsewhere, the gas may be too thin or too hot to collapse. Waves of density, created by spiral arm motion, pass through the disk and compress the gas in rhythmic cycles, igniting stars along narrow, curved bands. Observing these patterns helps astronomers understand how galaxies breathe, forming stars in pulses rather than continuously. Andromeda's uneven tapestry of light reveals that even on a galactic scale, creation unfolds in complex rhythms, with calm regions balancing the brilliant outbursts of cosmic energy that define its spiral beauty. The inner regions have slowed while the outskirts keep shining. In the central parts of the Andromeda galaxy, the raw material for star formation has gradually been consumed. Most of the gas there has either turned into stars or been blown outward by past stellar winds. As a result, the inner disk now glows primarily with older, longer-lived stars whose light is steady but subdued. In contrast, the galaxy's outer regions remain rich in cold hydrogen gas, allowing new stars to continue forming far from the center. This difference creates a kind of temporal layering within Andromeda, where the ancient heart coexists with a youthful rim. Studying this contrast allows astronomers to trace how galaxies evolve from active, star-forming systems into calmer, mature structures. The bright edges of Andromeda remind us that even an old galaxy still carries pockets of vitality, where the cosmic cycle of birth and renewal quietly continues among the outermost arms. Dust lanes swirl through the spiral arms like smoky ribbons. When viewed through powerful telescopes, the luminous arms of Andromeda are streaked with intricate dark lines. These are lanes of interstellar dust, composed of tiny grains of carbon and silicates left behind by dying stars. They absorb and scatter starlight, creating the appearance of smoky ribbons coiling through the glowing spiral. Within these dust lanes lie the cool, dense regions where stars are born. Far from being mere shadows, they are the fertile soils of the galaxy. Their complex shapes trace the movement of gas under Andromeda's gravity, revealing how matter flows and gathers along the spiral arms. Seen in infrared light, these lanes come alive, glowing faintly with warmth as they absorb radiation from nearby stars. Through their delicate patterns, we glimpse the quiet choreography of cosmic creation, the same process that once gave rise to the Sun, the Earth, and every atom of life we know. Infrared telescopes reveal these dark lanes glowing faintly with heat. To the naked eye or through ordinary optical telescopes, Andromeda's dust lanes appear as shadows against the light of its stars. But when astronomers observe in the infrared, those shadows vanish, replaced by a soft, luminous glow. The dust itself, warmed by nearby starlight, radiates faint heat that can only be detected at longer wavelengths. Using infrared observatories such as the Spitzer and James Webb Space Telescopes, scientists can peer through the veils of dust to see what lies beneath, uncovering young stars still wrapped in their birth clouds. These images reveal Andromeda's hidden architecture, showing how dust and gas weave together to shape its spiral form. What once looked like darkness becomes a tapestry of gentle warmth. The view reminds us that even in the coldest reaches of space, every particle carries energy, every shadow hides light, and every silence hums with unseen activity. Its ultraviolet glow shows where the youngest stars live. The Andromeda galaxy radiates not just invisible light, but across the full electromagnetic spectrum. When astronomers examine it in ultraviolet wavelengths, a different picture appears. The spiral arms blaze with bright, energetic patches where massive young stars are clustered together. These newborn stars emit vast amounts of ultraviolet radiation, heating and shaping the surrounding gas. By mapping this glow, scientists can trace the galaxy's most active star-forming regions and measure how rapidly it is still creating new stars. The ultraviolet image of Andromeda looks almost skeletal, revealing its inner framework of stellar nurseries glowing like embers within the spiral. Each bright region is a cosmic cradle, less than a few million years old. To see Andromeda in ultraviolet light is to watch it live and breathe in real time, a reminder that even ancient galaxies continue to create new light with steady, patient energy. Radio waves expose cold gas waiting to collapse into stars. Long before new stars ignite, their raw material exists as vast clouds of cold hydrogen. These regions do not shine in visible light, but they emit faint radio signals that astronomers can detect using giant radio telescopes. By tuning to the specific frequency of neutral hydrogen, scientists can map where this gas lies within Andromeda. The resulting image reveals enormous spiral patterns extending well beyond the visible disk, showing that Andromeda's structure continues far into space. This cold gas is the galaxy's reserve of future starlight, material that will one day collapse under gravity to form new suns and planets. Observing it allows astronomers to predict where the next generation of stars will appear. The radio view of Andromeda is therefore like a blueprint of its future, a quiet, invisible foundation for the brilliant stars that will one day light its arms again. Andromeda shines brightly in every wavelength of light. From radio to gamma rays, the Andromeda galaxy glows across the entire electromagnetic spectrum. Each wavelength reveals a different layer of its story. Radio waves show its cool gas and vast structure, while infrared light reveals the warmth of dust and newly formed stars. Visible light displays the grand spiral itself. Ultraviolet marks regions of high-energy youth, and X-rays uncover the violent remnants of exploded stars. Together, these layers form a complete portrait of a galaxy alive with complexity. No single view tells the whole truth. It is only by combining all these wavelengths that astronomers can see Andromeda's full personality, from the calm of its outer disk to the fierce energy near its core. To look upon it is to gaze across the entire spectrum of cosmic life, from birth to death, all woven together in one vast celestial masterpiece. From space, it is one of the most studied galaxies in the universe. Orbiting observatories have devoted countless hours to observing Andromeda. The Hubble Space Telescope has captured sweeping mosaics of its spiral structure, while instruments aboard the Chandra X-ray Observatory and the James Webb Space Telescope have examined its energetic core and dusty outskirts in exquisite detail. Andromeda serves as a nearby laboratory for understanding galaxies across the cosmos. Because it is close and similar in structure to our Milky Way, it allows scientists to study processes that would be impossible to observe clearly in more distant systems. Every wavelength, every image, adds to a collective understanding of how galaxies live, age, and interact. Andromeda is more than a distant smudge in the night sky. It is a cornerstone of modern astronomy, a benchmark against which we measure our knowledge of the universe and our place within its grand design. Early astronomers debated fiercely whether it was within our Milky Way. Before the 20th century, no one knew for certain what Andromeda truly was. Through early telescopes, it appeared as a faint, cloudy patch, sometimes called the Great Andromeda Nebula. Many astronomers believed it lay within our own Milky Way, a nearby cluster of stars shrouded in mist. Others suspected it might be something far larger, perhaps an entire island universe beyond our own. This debate became one of the most passionate questions in the history of astronomy. Without precise instruments to measure distance, the truth remained hidden. For centuries, Andromeda was both familiar and mysterious, visible to the eye, yet incomprehensible in scale. The argument over its nature reflected humanity's growing curiosity about the universe, a longing to understand whether our galaxy was unique or part of something much greater. That uncertainty persisted until a single observation finally settled the question once and for all. A famous photograph settled the argument once and for all. In the early 20th century, astronomers began to capture long-exposure photographs of the night sky. One of these images, taken by Edwin Hubble using the Hooker telescope at Mount Wilson Observatory, revealed something extraordinary within the Andromeda Nebula. Embedded among its glowing spirals were faint, pulsing points of light known as Cepheid variable stars. By measuring their brightness and the rhythm of their pulses, Hubble could calculate their distance. The result was staggering. These stars lay far beyond the boundaries of our Milky Way. The Andromeda Nebula was not a nearby cloud of gas, but a vast galaxy in its own right. That single photograph changed astronomy forever, transforming a mystery into a revelation. It opened humanity's eyes to the true scale of the cosmos, showing that our galaxy was merely one among countless others scattered through the immense fabric of the universe. Edwin Hubble proved it was far beyond our galaxy's edge. Using the light from Cepheid variable stars, Edwin Hubble calculated that Andromeda was more than 2 million light-years away. At that time, such a distance was almost unimaginable. The discovery shattered the long-held belief that the Milky Way contained all of creation. Andromeda became the first confirmed galaxy beyond our own, a window into the vastness of the universe. Hubble's precise measurements marked the birth of modern extragalactic astronomy. His work not only revealed the true nature of Andromeda, but also hinted at a much larger truth: that space was filled with galaxies of every shape and size, stretching endlessly in all directions. This breakthrough transformed humanity's view of its cosmic home. For the first time, we understood that we were part of an immense and expanding universe, filled with countless other worlds glowing in the dark. That discovery changed our understanding of the universe forever. When Edwin Hubble announced his findings in the 1920s, the scientific world was stunned. Until then, most astronomers believed that the Milky Way represented the entire cosmos. The realization that Andromeda was another galaxy, far beyond our own, expanded the known universe by an almost inconceivable amount. Overnight, the cosmos grew from a single island of stars into a vast ocean filled with countless galaxies. This discovery redefined humanity's place in existence, transforming our perception of scale, time, and possibility. It also paved the way for the discovery that the universe itself is expanding, a concept that continues to shape cosmology today. Andromeda thus became a symbol of perspective, a reminder that even the most familiar patch of sky can conceal wonders beyond imagination, waiting patiently for the moment when human curiosity grows sharp, enough to see them clearly. It marked the moment when we realized the Milky Way was not alone. Before Hubble's work, people looked up at the night sky, believing that every star belonged to our own galaxy. The revelation that Andromeda was another galaxy altogether changed that forever. It meant that our Milky Way was just one member of a much larger cosmic community. The universe suddenly became not a single city of stars, but an infinite archipelago, with galaxies as its islands. This recognition transformed astronomy from a study of our local surroundings into an exploration of the cosmos itself. It inspired generations of scientists and dreamers to look outward, beyond the limits of our own spiral arms. Every time we see Andromeda rising in the autumn sky, we are reminded of that turning point, when the boundaries of the known world dissolved and the universe opened wide before us, inviting us to keep exploring without end. The Andromeda Galaxy helped reveal that the universe is vast and expanding. After discovering that Andromeda was a separate galaxy, Edwin Hubble continued his research, observing other distant systems. He noticed that the light from most of them was stretched toward the red end of the spectrum, a sign that they were moving away from us. This observation led to one of the most profound conclusions in science. The universe itself is expanding. Andromeda, however, was a rare exception, moving toward us instead of away. Its approach became even more significant, showing that galaxies are not static dots in space, but dynamic participants in a grand cosmic motion. Through Andromeda, astronomers could measure both distance and velocity, linking observation to theory in a way that changed everything. It stands today as both a neighbor and a clue, a silent witness to the discovery that space and time themselves are not fixed, but alive with motion and growth. Its stars became the yardstick for measuring cosmic distances. The Cepheid variable stars that Edwin Hubble observed in Andromeda became the foundation for modern cosmology. These stars pulsate in brightness with a predictable rhythm, allowing astronomers to determine their true luminosity. By comparing that intrinsic brightness to how faint they appear from Earth, scientists can calculate their distance with remarkable accuracy. This method became known as the cosmic distance ladder, and Andromeda was its first crucial step. Every measurement of galaxies, clusters, and the expanding universe traces back to those same stars. The light from Andromeda's Cepheids not only revealed its immense distance, but also gave astronomers the tools to chart the cosmos itself. In this way, the stars of our nearest neighbor became the rulers by which the scale of the universe was first drawn, their steady pulsations still guiding our exploration of the infinite today. Cepheid variable stars in Andromeda were crucial to that measurement. Cepheid variables are remarkable stars whose brightness rises and falls in a precise repeating pattern. The length of each cycle depends directly on the star's intrinsic luminosity. By measuring that rhythm, astronomers can determine how bright the star truly is, and therefore how far away it must be. When Edwin Hubble identified Cepheidae variables within the Andromeda galaxy, he realized that they were far too faint to lie within our own Milky Way. That insight proved that Andromeda was a separate galaxy, vastly more distant than anyone had imagined. These stars thus became the foundation of cosmic measurement, allowing scientists to gauge distances across space. Their steady pulses turned light itself into a language of geometry and time, enabling us to map the universe one rhythm at a time, each cycle a heartbeat echoing through the dark of intergalactic space. They pulse in brightness, revealing how far away they are. Each Cepheid variable within Andromeda acts as a tiny, flickering beacon across millions of light years. As its surface expands and contracts, the star brightens and dims in a steady rhythm. By recording that pulse, astronomers can determine how luminous the star truly is. Comparing that intrinsic brightness to the faint light that reaches Earth yields its distance. This method was the key that unlocked the scale of the universe. The discovery that these stars in Andromeda were so distant showed that our galaxy is only one among billions. Today, the same technique is still used, refined by modern telescopes to measure galaxies far beyond Andromeda. These stars continue to beat their silent rhythm across cosmic time, their light arriving as a steady message from the past, telling us not only where they are, but how far human understanding has traveled since we first saw them. Their light confirmed that Andromeda lies millions of light-years distant. When Edwin Hubble measured the brightness of Cepheidae variable stars within the Andromeda galaxy, he found that they were far fainter than they would be if they existed within our own Milky Way. The only explanation was distance, an almost unimaginable gulf of millions of light-years. That faint light had been traveling toward us since long before humans walked the Earth, crossing the silent void between galaxies. Each flickering pulse of a Cepheid star carried precise information about its true luminosity and distance, And when Hubble compared the two, the result was undeniable. Andromeda was not a local nebula, but a vast island of stars existing far beyond the borders of our galaxy. This realization reshaped our understanding of the cosmos, revealing that the universe extended much farther than anyone had dreamed. And that light itself could serve as the ultimate messenger between worlds separated by immense stretches of space and time. That discovery made the universe suddenly much larger. Before Edwin Hubble's measurements, astronomers believed the Milky Way contained everything that existed. When his calculations showed that Andromeda was millions of light-years away, the known universe expanded in an instant. The Milky Way was no longer the entirety of creation, but one among countless galaxies drifting through space. The scale of existence increased from thousands of light-years to billions. The discovery altered not just science, but perspective. Humanity realized it inhabited a tiny world orbiting a modest star, within a single galaxy that was itself a speck in a limitless cosmos. The Andromeda revelation became a moment of awakening, much like the first time people understood that Earth revolves around the Sun. The universe was no longer a single structure, but an infinite landscape, vast and filled with possibilities, where every faint glow in the sky could be another galaxy, home to uncounted stars and worlds beyond. Imagination. The Andromeda galaxy moves toward us faster than 200 kilometers per second. Unlike most galaxies, which drift away as the universe expands, Andromeda is on an inbound path. Measurements of its light show a slight shift toward the blue end of the spectrum, meaning it is approaching. The speed is astonishing, over 200 kilometers every second. Though it sounds rapid, the distance between our galaxies is so great that the collision will not occur for billions of years. Andromeda's motion is driven by the mutual gravity between our two massive systems, each pulling gently on the other across space. This approach is not violent but inevitable, part of the slow choreography that governs galaxies within the local group. As they draw nearer, their halos already begin to overlap, mingling invisible gas and dark matter. The faint blue shift in Andromeda's starlight is our first subtle clue that we are connected, that our future and Andromeda's are destined to intertwine on a galactic scale. Gravity will eventually draw our galaxies together. The pull between the Milky Way and the Andromeda galaxy is unrelenting. Over billions of years, their mutual gravity acts like a slow but steady tide, bringing them closer together despite the general expansion of the universe. In roughly 4 billion years, the two galaxies will begin to merge, their stars and gas clouds interacting in an immense cosmic dance. Gravity will stretch their spiral arms into great arcs of light, blending them into new patterns. This is not an unusual event, but a natural part of galactic evolution. Collisions like this have shaped the universe for billions of years, creating larger and more complex galaxies from smaller ones. The meeting of Andromeda and the Milky Way will not be a catastrophe, but a transformation. A graceful slow-motion convergence that will reshape both into something entirely new, bound forever as a single, grand structure, glowing deep within the night of the future cosmos. When they collide, stars will rarely hit each other. Although the Milky Way and Andromeda each contain hundreds of billions of stars, the spaces between those stars are vast beyond comprehension. If two galaxies were to overlap completely, the chance of any two stars colliding directly would be almost zero. Instead, the collision will be gravitational. The orbits of stars will shift, bending under the combined pull of both galaxies. Some will be flung into long tidal tails stretching thousands of light-years across, while others will settle into new paths around a shared center. Clouds of gas, however, will collide and compress, igniting bursts of star formation that will fill the sky with new light. The event will not be one of destruction, but of reorganization. From the perspective of a distant observer, it will look like two glowing spirals embracing and slowly merging into a single radiant entity that continues shining peacefully amid the deep and endless dark. Instead, their orbits will simply shift and reshape. When the Andromeda galaxy finally meets our own, gravity will become the sculptor of an entirely new celestial landscape. Stars that once orbited in stable circles will begin to trace elegant, looping paths through the merged gravitational field. Some may be cast outward into vast arcs that stretch beyond the edges of the combined system. Others will fall inward, forming a dense, brilliant core. Over time, the two spiral patterns will lose their symmetry, transforming into a single, elongated structure. The motions of billions of stars will gradually settle into new orbits, guided by the distribution of mass within the merging galaxies. Simulations show that after the chaos of the first encounter, the system will relax into harmony once again. The night sky from within that future galaxy will be utterly transformed, filled with streams of light tracing the memory of two galaxies that became one. The night sky of the future Earth will be breathtaking. If humanity or its descendants still exist billions of years from now, they will witness a cosmic spectacle unlike any other. As Andromeda approaches, it will grow larger and brighter in the night sky, transforming from a faint smudge into a luminous, sprawling disk. Eventually, its spiral arms will become visible to the naked eye, filling the heavens with delicate arcs of light. During the merger, the sky will be dominated by glowing streams of stars stretching across space like rivers of fire. From Earth's surface, the view will be both surreal and magnificent, a display unfolding over millions of generations. Though the process will be slow, its beauty will be unmatched. The stars will not vanish, but rearrange themselves into new constellations. The future night will shimmer with evidence that galaxies, like living things, are born, grow, and merge, leaving behind breathtaking traces of their union across the sky. The two galaxies will stretch into long tidal streams of light. As Andromeda and the Milky Way approach one another, their mutual gravity will distort their spiral arms, pulling stars and gas into immense arcs that trail behind them. These elongated formations are called tidal streams, shaped by the same forces that raise ocean tides on Earth, though on a scale billions of times greater. Each stream will contain billions of stars stretched thin across intergalactic space. Some of these streams will later fall back toward the merging core, while others will drift away, becoming faint ribbons of starlight lost to the void. Astronomers have observed similar streams around other galaxies, giving us a preview of what our own future collision will create. These glowing bridges of light will be visible for billions of years, delicate reminders of the gravitational connection that once drew two spiral galaxies together and reshaped them into a single, luminous whole. Eventually, they will settle into one enormous elliptical galaxy. After the long sequence of close encounters, tidal distortions, and swirling collisions, the Milky Way and Andromeda will finally merge into a stable structure. Over billions of years, their orbits will lose their organized spiral form, replaced by a more rounded, elliptical shape. The new galaxy will be enormous, containing the combined stars, gas, and dark matter of both. Astronomers call such a system a giant elliptical galaxy, and they have observed many examples throughout the universe. The central black holes of the two original galaxies may eventually merge as well, releasing waves of gravitational energy that ripple across space-time. Though the details will take eons to unfold, the result will be serene, a vast glowing spheroid of stars shining quietly in the cosmic dark. Some astronomers have already given this future galaxy a name, a poetic combination of both parents, calling it simply Milkomeda. That process may take billions of years to complete. The collision and merger between Andromeda and the Milky Way will not be a single dramatic event, but a slow evolution lasting several billion years. When the galaxies first meet, they will pass through one another, continue outward, and then be drawn back again by gravity for repeated encounters. Each pass will distort their shapes further, creating loops and streams of stars that slowly settle into new configurations. The process of merging will take so long that entire generations of stars will be born and die during it. Eventually, the chaotic motion will fade, replaced by the smooth symmetry of a single elliptical galaxy. The timescale is beyond ordinary imagination, but in the rhythm of the universe, such events are common and natural. Time itself will be the sculptor, shaping two ancient spirals into one enduring monument of starlight and silence spread across the deep. Our solar system will likely drift unharmed within it. Although the future merger between the Milky Way and Andromeda will dramatically reshape both galaxies, the spaces between individual stars are so vast that the Sun and its planets will almost certainly remain untouched. The solar system will continue its slow orbit, simply shifting position within the new galactic structure. It may find itself cast farther from the center or drifting among unfamiliar constellations, but it will survive the encounter intact. Over time, the view of the night sky will change completely. New clusters of stars will appear, and the Milky Way's familiar band may fade as its structure transforms. Yet the sun will keep shining, Earth will continue to orbit, and the sky will remain filled with light. The cosmic collision that seems so monumental from afar will pass around us almost gently, leaving our small corner of the universe still warm and alive. Alien civilizations in Andromeda might already know about us. If intelligent beings exist somewhere within the Andromeda galaxy, they might have long ago turned their telescopes toward the Milky Way. From their vantage point, they would see our galaxy as it appeared more than 2 million years ago, since light from Earth and the Sun takes that long to reach them. If their technology were advanced enough, they might even detect the faint spectral signature of life in our atmosphere, the same way we search for biosignatures on exoplanets. To them, humanity would not yet have evolved. They would see only a primordial Earth, bathed in starlight. Similarly, when we observe Andromeda, we are seeing its distant past, not its present. Any civilizations there are looking back at an earlier version of us, just as we are looking back at theirs. The two galaxies are already connected, not by touch, but by the timeless exchange of light. Their astronomers would see our galaxy as it was long ago. If observers in Andromeda were to look at the Milky Way through powerful telescopes, the image they would see is not our galaxy as it exists now, but as it appeared millions of years in the past. The finite speed of light means that every observation is also a look backward through time. They would see the Milky Way before humanity existed, perhaps even before the rise of the first mammals. From their perspective, our sun would appear young, and the spiral arms of our galaxy might look subtly different. This time delay works both ways. Our view of Andromeda is equally ancient. The space between galaxies is therefore also a space between moments, a living archive of the past, written in light. When we gaze at Andromeda's glow, we are not looking across empty distance, but into history itself, illuminated by stars that shine from ages long gone. Communication between us would take millions of years each way. If an intelligent civilization within Andromeda ever attempted to contact us, their signal would need to travel more than 2 million light-years through intergalactic space. Even at the speed of light, that message would take over 2 million years to arrive. A reply would take just as long to return. By the time the conversation reached its second message, both civilizations might have long since changed or vanished. The vastness of space makes such exchanges impractical, yet the thought itself is profound. It highlights the immense scale of the cosmos and the isolation of each world within it. Every light beam, every radio signal becomes a kind of time capsule, a whisper cast into the dark that may one day be heard by distant minds living in an entirely different epoch. Across that silence, the universe remains patient, always listening. Some of Andromeda's planets may host habitable conditions. Within the countless star systems of the Andromeda galaxy, many planets surely orbit in the temperate zones where liquid water could exist. Although we cannot yet see them directly, statistical models suggest that millions of Earth-like worlds may lie scattered across its spiral arms. Around stable, sun-like stars, some of these planets might have maintained atmospheres and climates suitable for life. Others could host icy moons warmed by tidal forces, or oceanic worlds blanketed in clouds. Future generations of telescopes may one day detect the faint spectral signatures of such places, revealing oxygen, methane, or other markers of biological activity. The idea that Andromeda could hold entire civilizations of life forms, each beneath its own star, stretches the imagination. It reminds us that the universe's capacity for variety and wonder is likely beyond anything we have yet discovered, or even dreamed. Others could orbit exotic stars very different from our Sun. Not all stars in Andromeda resemble the familiar warmth of our Sun. Some are enormous blue giants, radiating fierce ultraviolet light and living only a few million years. Others are tiny red dwarfs, faint and cool, capable of burning for trillions of years. Planets orbiting such stars would experience entirely different environments. Around blue giants, a world might be bathed in intense radiation and heat, while near a red dwarf, the same planet could be locked in eternal twilight, with one side facing the star forever. Some stars exist in binary pairs, giving rise to planets that orbit two suns at once, casting double shadows. The diversity of stars in Andromeda ensures an equally vast diversity of worlds. Each system could tell a different story of chemistry, atmosphere, and light, offering endless possibilities for life and exploration throughout the galaxy's radiant expanse. Rogue planets may drift between its stars in the dark. Not every planet in Andromeda belongs to a particular star. Some have been ejected from their home systems during gravitational encounters and now wander freely through the dark, untethered and alone. These rogue planets drift silently between the stars, their surfaces frozen and their skies forever black. Yet some may still hold warmth deep within, generated by radioactive decay or lingering internal heat. A few might carry subsurface oceans beneath thick layers of ice, hidden refuges for potential microbial life. Astronomers estimate that there could be more rogue planets than stars in a typical galaxy, meaning Andromeda may contain trillions of these unseen worlds. They are the drifters of the cosmos, each one a lonely traveler moving endlessly through the quiet spaces between suns. Reminders that even in the darkness, the universe is filled with possibilities waiting to be found. The galaxy's population of stars includes nearly every known type. Within Andromeda's vast expanse, there exists an extraordinary diversity of stars. The galaxy contains brilliant blue supergiants, aging red giants, compact white dwarfs, and neutron stars that spin with incredible speed. It also holds vast populations of ordinary sun-like stars and countless faint red dwarfs that make up the bulk of its stellar mass. This mixture of types provides a complete laboratory for studying stellar evolution. By observing Andromeda, astronomers can see every phase of a star's life, from its birth within glowing nebulae to its final moments as a cooling ember. The variety of stars also shapes the galaxy's colors, with young regions shining blue and older zones glowing red. Each type of star contributes to the galaxy's rhythm, and together they create a living mosaic of light that represents nearly every possibility of stellar existence found in the universe. There are immense clusters of old globular stars surrounding it. Encircling Andromeda's luminous disk are hundreds of globular clusters, dense, spherical gatherings of ancient stars that have orbited the galaxy for billions of years. Each cluster contains hundreds of thousands of suns packed into a space only a few dozen light-years wide. These stars are among the oldest in existence, formed when the universe itself was still young. Their light is soft and golden, their motion stable and serene. Studying them allows astronomers to look back into the earliest epochs of galactic history, revealing how Andromeda and its companions first assembled. The globular clusters form a kind of halo crown around the galaxy, glowing faintly at its edges. Within them may lie relics of long-lost systems absorbed during Andromeda's growth. They are the ancient guardians of the galaxy, orbiting silently as they have for eons, preserving the memory of a time when the first stars began to shine. Some of those clusters are among the largest ever found. Among Andromeda's many globular clusters, a few stand out as extraordinary. One, known as Mayol 2 or G1, is not only the largest in Andromeda, but one of the largest star clusters ever observed. It contains several million stars bound tightly by gravity, making it more massive than many small galaxies. G1 is so bright that it can be seen with modest telescopes, shining as a faint point just beyond the galaxy's edge. Astronomers believe it may be the remnant core of a dwarf galaxy that Andromeda absorbed long ago, stripped of its outer layers but still holding together as a dense sphere of ancient stars. Clusters like this act as fossils of cosmic history, preserving clues about Andromeda's growth and the mergers that shaped it. They demonstrate that even within the calm of a star cluster lies a story of creation, collision, and endurance written in light. Others show signs of strange, unknown dynamics. Among the many globular clusters that orbit Andromeda, some behave in ways that defy easy explanation. Their stars move in unexpected patterns, spinning faster or slower than gravity alone should allow. In a few cases, the clusters appear to be slightly elongated or distorted, as if something unseen were tugging at them. Astronomers suspect these odd motions may hint at the influence of dark matter or at remnants of small galaxies that were once part of Andromeda's early history. The strange dynamics within these clusters act like fingerprints of long-ago cosmic events, perhaps the merging of two clusters or the passing shockwave of a nearby collision. Each cluster tells a different story, its movement recorded in the slow language of gravity and time. Studying them helps scientists uncover how Andromeda evolved, revealing subtle clues about its hidden mass and the mysterious forces that continue to shape its halo. The galaxy's magnetic field stretches for thousands of light-years. Although invisible to human eyes, Andromeda possesses a vast magnetic field that weaves through its spiral arms and surrounding halo. Radio observations show that these magnetic lines of force trace elegant patterns following the motion of gas and stars. Stretching for thousands of light-years, the field influences how charged particles move within the galaxy. It is thought to arise from the rotation of Andromeda's disk, combined with the movement of ionized gas, which together act like a dynamo. Magnetic fields of this kind play an important role in the life of galaxies, guiding the flow of cosmic rays, shaping interstellar clouds, and possibly affecting the rate at which stars form. Though intangible, Andromeda's magnetic field is one of its most beautiful hidden features, an unseen web that connects its stars and nebulae in a delicate, ever-changing balance of energy and motion. It may influence the motion of cosmic rays through its disk. High-energy particles, known as cosmic rays, constantly stream through the universe. Within Andromeda, these particles move along the paths carved by the galaxy's magnetic field. The field channels and redirects them, preventing their motion from being entirely random. As the cosmic rays spiral through space, they interact with gas and dust, creating faint radio and gamma-ray emissions that astronomers can detect from Earth. These observations help scientists trace the strength and structure of Andromeda's magnetism. Understanding how cosmic rays behave within a galaxy also reveals how energy circulates on a cosmic scale, transferring momentum and heat through the interstellar medium. The process is complex and ongoing, a quiet interplay between invisible particles and the magnetic architecture that guides them. In this way, Andromeda demonstrates how even the smallest forces can shape the rhythm of an entire galaxy, unseen yet ever present in its eternal flow. Gamma-ray telescopes have detected mysterious high-energy emissions. When astronomers observed Andromeda using space-based gamma-ray telescopes, they found something unexpected. The galaxy emits faint but distinct gamma radiation, the most energetic form of light. These emissions do not come from ordinary stars, but from regions that seem devoid of any visible sources. One explanation is that the radiation may originate from the decay or interaction of dark matter particles, though this remains unconfirmed. Another possibility is that the light is produced by the acceleration of cosmic rays in Andromeda's magnetic field. Whatever the cause, these gamma signals reveal that the galaxy is far from quiet. Deep within its halo, processes of immense energy unfold continuously, releasing photons powerful enough to cross millions of light-years. Each detection offers a new clue about the invisible forces at work within the universe, reminding us that even the calmest galaxy can conceal astonishing activity in its hidden depths. These signals might hint at dark matter interactions. Dark matter cannot be seen or touched, but it may reveal itself through the faint light produced when its particles interact. The mysterious gamma-ray glow detected in Andromeda's halo has led some scientists to wonder if they are witnessing exactly that phenomenon. According to certain theories, when dark matter particles collide, they can annihilate one another, releasing a burst of high-energy radiation. If this is true, the Andromeda Galaxy could serve as a natural laboratory for studying one of the universe's greatest mysteries. Detecting such interactions would provide direct evidence for the existence of dark matter and help identify its properties. Though the signals are faint and uncertain, their potential significance is profound. They suggest that Andromeda's tranquil appearance hides a deeper story, one written not in stars or light, but in the invisible physics that governs the very structure of the cosmos itself. X-ray observations reveal hot gas and compact stellar remnants. Andromeda does not shine only in visible light. When observed in the X-ray spectrum, the galaxy reveals a very different landscape. Scattered across its disk and halo are countless points of intense radiation, many of them created by the remains of dead stars. Neutron stars, white dwarfs, and black holes feed on nearby material, heating it until it emits X-rays. Between these compact objects lie vast clouds of hot gas, reaching millions of degrees in temperature. These glowing regions are evidence of energetic processes that continue long after the explosions of supernova. The X-ray light provides insight into the galaxy's ongoing life cycle, showing how energy from dying stars influences the formation of new ones. Through these observations, astronomers can see both the violence and the renewal that coexist within Andromeda, the endless transformation that defines its evolution across cosmic time. Some of its brightest X-ray sources are black hole binaries. Among the points of intense X-ray light scattered throughout Andromeda, A few stand out as particularly brilliant. These are thought to be binary systems containing a black hole and a companion star. As the black hole's gravity pulls matter from the nearby star, the material forms a swirling disk that heats to incredible temperatures, releasing floods of X-rays before disappearing beyond the event horizon. Such systems are rare and powerful, visible even across the vast gulf of space separating Andromeda from the Milky Way. Observing them allows scientists to study how black holes grow and how energy is released from the most extreme environments known. Each one is a miniature drama of creation and destruction, a cosmic engine where gravity, motion, and light all meet in a balance so intense that it challenges the limits of human understanding and the boundaries of what light can endure. Andromeda has experienced many bursts of star formation over time. The Andromeda galaxy has not always been steady in its creation of stars. Over the course of billions of years, it has gone through periods of intense activity when vast numbers of stars were born in rapid succession. These bursts of formation left lasting imprints on the galaxy's structure, filling its spiral arms with brilliant clusters of young blue suns. Astronomers believe these periods were triggered by gravitational interactions with neighboring galaxies, which compressed clouds of gas and set off waves of creation. Between these outbursts, Andromeda entered calmer phases when star formation slowed, allowing the gas to cool and settle. This rhythmic cycle of activity and rest mirrors the natural breathing of a galaxy, a cosmic heartbeat that pulses through time. Each generation of stars carries within it the memory of those ancient bursts, shining as reminders of the galaxy's ever-changing vitality. These bursts may have been triggered by galaxy mergers. Galaxies do not exist in isolation. They often interact, collide, and merge over long timescales. In Andromeda's history, such encounters have likely occurred many times. When a smaller galaxy passes through or near Andromeda, the resulting gravitational forces compress its gas and dust, sparking massive waves of star formation. Evidence of these events is preserved in the arrangement of stars, in the warped shape of the disk, and in the faint streams that extend beyond its visible edges. These past mergers are not only records of destruction, but also moments of renewal. They infused Andromeda with fresh material and energy, helping it grow into the immense structure we see today. Every star that shines in its spiral arms may owe its birth to one of these encounters, each merger a quiet but powerful act of cosmic creation written across billions of years. Ancient collisions left faint scars visible in its halo. Beyond the bright disk of Andromeda lies a vast halo filled with the remnants of long-ago collisions. Faint arcs and wisps of stars mark the paths of smaller galaxies that were torn apart and absorbed into the larger whole. These ghostly trails are difficult to see, but with sensitive instruments, astronomers can trace them like fingerprints left on the fabric of space. Each one tells the story of a merger that occurred billions of years ago, when the universe itself was still young. By studying their shapes and motions, scientists can reconstruct the timeline of Andromeda's growth, revealing how it has evolved through countless interactions. The halo, though faint, is alive with memory. Every star that drifts within it is part of an ancient echo, a quiet testimony to the collisions and assimilations that built one of the most majestic galaxies in the nearby universe. The faint screams of stars act as a fossil record of those events. Surrounding the main body of the Andromeda galaxy are delicate, thread-like streams of stars that stretch for hundreds of thousands of light-years. These are the remains of smaller galaxies that were drawn in by Andromeda's gravity and gradually torn apart. Their scattered stars now form shimmering trails that trace the orbits they once followed. Astronomers call them stellar streams, and they serve as a kind of fossil record, preserving evidence of events that took place billions of years ago. By studying their position and motion, scientists can piece together the story of Andromeda's formation, much as archaeologists reconstruct history from ancient ruins. These star streams reveal that galaxies grow by consuming others, a process of continual renewal that never truly ends. In their faint light lies the memory of creation, written across the quiet outskirts of a galaxy still gathering itself from the dust of the past. Its stellar halo extends far beyond what we once imagined. For many years, astronomers believed Andromeda's visible edge marked the limit of its domain. But deeper observations have shown that its stellar halo reaches much farther, extending well beyond the regions where stars are easily seen. This halo contains faint, scattered populations of stars stretching nearly halfway to our own galaxy. It also includes globular clusters, stellar streams, and clouds of hot gas. The discovery of its immense extent has changed our understanding of what defines a galaxy's true size. Andromeda is not just the bright spiral we see through telescopes, but an enormous gravitational structure that fills a significant portion of the local group. Its halo is a blend of the old and the new, containing both ancient stars from early epochs and debris from more recent mergers, a vast, invisible frontier that connects it subtly to the intergalactic space beyond. That halo contains both ancient stars and new arrivals. Within Andromeda's enormous halo, astronomers have identified stars of many different ages. Some are among the oldest in the universe, dating back to the time when galaxies were first forming. Others appear to be much younger, likely stripped from smaller galaxies that have recently merged with Andromeda. This mixture reveals that the halo is not static, but constantly evolving. Stars are added through ongoing interactions, while old ones drift ever farther outward over time. The halo therefore serves as both a museum and a construction site, preserving relics of the distant past while welcoming the products of more recent cosmic events. It is through studying this complex environment that scientists learn how galaxies assemble their mass and structure. Every star within the halo adds a thread to the continuing story of Andromeda's growth, a story still unfolding across the endless night of intergalactic space. The outer halo merges almost seamlessly with intergalactic space. Far from Andromeda's bright core, its outer halo thins gradually until it becomes indistinguishable from the vastness that lies between galaxies. There is no clear border, no edge where one ends and the other begins. Instead, stars and gas fade into the dark, merging with the faint background of intergalactic space. This boundaryless transition shows that galaxies are not isolated islands, but overlapping structures within a continuous cosmic web. The outer halo is where Andromeda's gravitational influence gives way to the gentle tug of the universe at large. Within that region, stray stars and drifting clusters wander freely, no longer bound to any clear center. Observing this outer realm gives astronomers a rare glimpse into the connection between galaxies and the larger environment that surrounds them. It is the quiet edge of a system that never truly ends, only softens into infinity. Some of its stars are older than our own Sun by billions of years. Many of the stars scattered throughout Andromeda's halo were born long before the Sun came into being. Some may be more than 10 billion years old, formed when the universe was still in its early youth. These ancient suns have spent eons burning slowly, their light unchanged, while entire civilizations have risen and fallen on distant worlds. Studying them allows astronomers to look back into the conditions that existed near the dawn of time. Their composition reveals that they contain very few heavy elements, meaning they formed before the universe was enriched by generations of supernova. In their faint glow lies a record of the earliest chemical and physical processes that shaped all later stars. These venerable lights continue to shine quietly within Andromeda's vast domain, linking the galaxy's present grandeur to the deep origins of the cosmos itself. Others are just beginning their lives in glowing nebulae. Even within a galaxy filled with ancient stars, creation continues. In Andromeda's spiral arms and diffuse gas clouds, new suns are being born at this very moment. Within glowing nebulae, gravity draws cold hydrogen into dense knots that collapse and ignite. These young stars light up their surroundings with brilliant energy, causing nearby gas to shimmer in hues of pink and red. Some are massive and short-lived, while others resemble our sun and may live for billions of years. The contrast between the newborn stars and their ancient neighbors tells the story of continuity, a cycle that has never stopped since the galaxy first formed. Each new star carries within it the recycled material of countless generations before, proving that even in a universe billions of years old, creation is still underway, eternal and ongoing within the quiet glow of Andromeda's starlit clouds. Its chemical composition tells a story of gradual enrichment. The elements that make up Andromeda's stars reveal the history of its growth. The oldest stars contain little more than hydrogen and helium, the simplest ingredients of the early universe. Younger stars, however, show traces of heavier elements such as carbon, oxygen, iron, and gold. These were created inside previous generations of stars and scattered across the galaxy when those stars died as supernova. Over time, this cycle of creation and destruction enriched Andromeda's gas clouds, making each new generation of stars more complex in composition. By analyzing the light from these stars, astronomers can reconstruct this long chemical evolution, tracing how the galaxy transformed from a primordial swirl of simple gases into a rich environment capable of forming planets and, perhaps, life. In this way, Andromeda's chemistry serves as both a timeline and a testament to the endless renewal of matter in the cosmos. Each generation of stars has seeded the next with heavier elements. When a massive star reaches the end of its life, it explodes as a supernova, scattering its enriched contents into space. The gas and dust released mix with surrounding material, eventually forming new clouds from which fresh stars are born. Each new generation carries more heavy elements than the last, slowly transforming the galaxy's overall composition. In Andromeda, this process has unfolded for billions of years, turning simple hydrogen into a complex blend of cosmic ingredients. The oxygen we breathe, the carbon in our bodies, and the iron in our blood all originated in such stellar furnaces. Andromeda's shimmering light is therefore not only the glow of distant suns, but also the evidence of a continuing cycle of creation. The galaxy is a vast alchemist, forever transmuting the simple into the complex, forging the building blocks of life in the endless rhythm of its stars. Many of its planetary systems may contain those same elements. As stars in Andromeda formed from gas enriched by countless generations of predecessors, their surrounding planets inherited those same elements. Worlds orbiting these stars likely contain rocky surfaces, metallic cores, and carbon-based molecules similar to those found on Earth. Some may have oceans or atmospheres filled with water vapor, carbon dioxide, or methane. Others might host icy rings or volcanic moons. The presence of these elements suggests that the conditions necessary for complex chemistry, and possibly even life, may be widespread throughout the galaxy. Although we cannot yet see these distant worlds, the light from their parent stars carries the signatures of the materials that shape them. In this way, Andromeda mirrors our own Milky Way, a galaxy filled with the raw ingredients of life scattered among billions of stars. Each system is a quiet possibility, waiting to be discovered across the great gulf of space. The galaxy's brightness varies subtly with time. To the naked eye, Andromeda appears steady and constant, yet precise measurements show that its brightness changes slightly over long periods. These variations arise from supernova, variable stars, and shifting patterns of dust and gas that affect how its light reaches us. Some regions grew brighter as new clusters of young stars form, while others dim as massive stars burn out. Even the movement of interstellar dust can cause tiny fluctuations in its apparent glow. Though the changes are subtle, they reveal that a galaxy is not a static structure, but a living system, breathing slowly through cycles of creation and decline. Observing these small shifts over time allows astronomers to track Andromeda's ongoing evolution. Its light, steady yet ever-changing, is a cosmic heartbeat visible across the ages, a gentle reminder that even the most distant things are alive with motion. This variation reveals the slow heartbeat of star formation cycles. The Andromeda galaxy lives and breathes on a scale far greater than our own. Across its immense spiral disk, light rises and fades in a rhythm that unfolds over millions of years. Astronomers studying its brightness have found slow, repeating variations that trace the pace of creation itself. Waves of gas collapse to form clusters of newborn stars, then quiet as the material is used up or blown away by stellar winds. The galaxy brightens, dims, and brightens again, following a steady pulse that can only be measured through patient observation across the ages. It is as though the galaxy possesses a heartbeat of its own, one that beats not in seconds, but in eras. To witness these subtle changes is to sense a kind of cosmic breath, the universe inhaling and exhaling light, creating and resting in a balance as timeless as gravity itself. Astronomers can even detect the rotation of the galaxy itself. Andromeda turns in space with a grace too slow for any eye to see. Astronomers discovered its rotation by observing the colors of its light. One side of the galaxy drifts slightly toward us, and its light shifts to a faint blue. The opposite side moves away, and its light becomes subtly red. These changes reveal that the entire galaxy is rotating, its billions of stars orbiting a common center that holds a supermassive black hole. Each point of light we see is part of that grand movement, a fragment of a vast celestial wheel that turns with unhurried precision. It takes hundreds of millions of years to complete a single revolution, yet the pattern never falters. By tracing its rotation, scientists can weigh the galaxy, uncovering the invisible presence of dark matter that surrounds it and binds its stars within an unseen halo of gravity. It takes hundreds of millions of years to complete a single turn. The rotation of the Andromeda galaxy is so immense that one complete revolution requires hundreds of millions of years. In that time, entire species could rise and vanish on worlds orbiting distant stars, while the galaxy continues its patient motion undisturbed. Every star, cloud, and cluster follows its own orbit, yet together they create the grand spiral we see from afar. Gravity holds everything in balance, pulling inward as motion pulls outward, maintaining harmony over unimaginable time. Even the Milky Way, vast as it is, would seem to drift like a leaf beside such a cosmic current. To imagine Andromeda's slow turning is to glimpse the deeper rhythm of the universe, where time stretches beyond comprehension. The galaxy moves not with haste, but with certainty, carrying within its ancient rotation the record of billions of suns that have lived, shone, and passed back into starlit dust. The spiral pattern remains remarkably stable across vast timescales. Though its stars are constantly moving, the Andromeda galaxy's spiral arms have held their graceful form for billions of years. These arms are not permanent lines of stars, but waves of density that move through the disk like ripples across water. Where the waves pass, gas is compressed, and new stars ignite in brilliant clusters. As they drift onward, Those regions fade and new ones take their place, yet the pattern remains the same. Gravity, motion, and the flow of interstellar gas sustain this delicate architecture through time. Even as the galaxy evolves, its shape endures, a stable harmony within a universe defined by change. To see Andromeda's spirals is to witness order emerging from motion, a balance so perfect that it seems alive. The arms are not merely features of light, but echoes of timeless forces shaping the structure of creation itself. Andromeda has a companion galaxy called Messier 32. Nestled just below Andromeda's bright disk lies a smaller galaxy known as Messier 32. It appears as a smooth oval glow, compact and dense compared with the sprawling arms of its vast neighbor. Though it contains only a fraction of Andromeda's stars, it is remarkable in its own right, a sphere of ancient suns gathered tightly together. Astronomers believe that Messier 32 once had outer layers that were stripped away by Andromeda's gravity during past encounters. These close interactions may have shaped both galaxies, warping Andromeda's disk and altering its internal motion. Today, Messier 32 orbits as a loyal companion, forever influenced by the pull of the larger spiral. It is a quiet reminder that even small galaxies play essential roles in the stories of greater ones. In its soft glow, we see the subtle traces of cosmic companionship written in light and gravity. Another smaller neighbor, Messier 110, orbits it as well. Farther from Andromeda's shining core drifts Messier 110, another elliptical galaxy that moves gently through its gravitational field. This companion is larger than Messier 32, but still far smaller than Andromeda itself. It glows faintly with the red light of old stars, its gas long since stripped away by the pull of its massive neighbor. With time, it too will likely merge into Andromeda's growing halo, its stars absorbed into the greater whole. These companions are not mere satellites, but participants in the slow dance of galactic evolution. Each orbit changes them, shaping their forms and histories in quiet, imperceptible ways. Astronomers study them to understand how galaxies interact and grow through merging and exchange. Messier 110 moves through space like a drifting ember beside a blazing fire, small but luminous, destined to become one with the greater light. These companions may one day merge into its larger body. The small galaxies that circle Andromeda are slowly spiraling inward, drawn by its immense gravity. Over countless ages, their orbits will decay until they fall into the larger spiral and are absorbed. Such mergers have happened many times before, leaving faint trails of stars that wind through Andromeda's halo like pale rivers of light. Each merging adds new mass, new stars, and new stories to the growing galaxy. The process is gentle and gradual, taking place over billions of years, but its effects are profound. It is through these quiet collisions that galaxies evolve and renew themselves. What begins as separation becomes unity. What once orbited becomes part of the whole. The companions of Andromeda are already on this path, their futures written in motion. They remind us that in the cosmos, endings are often beginnings, wearing the shape of light. Gravitational tides already distort their shapes. Even now, the smaller galaxies orbiting Andromeda show signs of its gravitational power. Their once rounded forms appear stretched, as if drawn toward their vast companion. Streams of stars trail behind them, faint and ghostly, invisible to the eye but revealed by sensitive telescopes. These delicate threads mark the slow unraveling of entire galaxies, pulled apart by tidal forces that act across light years. In time, the stars from these streams will blend into Andromeda's halo, becoming indistinguishable from its own. Astronomers use these distortions to study the structure of Andromeda's dark matter halo, which extends far beyond what can be seen. Each distorted shape is a signature of invisible gravity at work. What we witness in these faint traces is not destruction but transformation, the universe reshaping itself slowly and beautifully under the unbroken guidance of its own natural order. Andromeda belongs to the local group of galaxies. Andromeda is not isolated in space, but part of the galactic family known as the local group. This cluster includes more than 50 galaxies, from vast spirals like Andromeda and the Milky Way to small, dim dwarfs scattered throughout the surrounding space. They are bound together by gravity, orbiting a shared center of mass and drifting collectively through the dark. The local group spans millions of light years, yet its members remain connected, moving in a complex web of interactions that shape their destinies. Within it, galaxies merge, exchange material, and influence one another's paths. Andromeda, being the largest, plays a dominant role, its gravity felt far beyond its visible edge. The local group is our home region of the universe, a quiet neighborhood in the grand cosmic architecture, where the stories of galaxies intertwine like stars, woven into a single vast constellation. That group also includes the Milky Way and dozens of dwarfs. The Milky Way and Andromeda are the twin giants of the local group, surrounded by many smaller galaxies that orbit them. Some are irregular clouds of stars and gas, while others are spherical clusters of ancient suns. These dwarfs move through space in intricate patterns, bound to their larger companions by gravity. Their orbits can last billions of years, and sometimes they pass close enough to be torn apart, adding their stars to the halos of greater systems. Though small, they play an essential role in galactic evolution, acting as the building blocks from which larger galaxies grow. The Milky Way and Andromeda each command dozens of these companions, together forming a miniature ecosystem of cosmic interactions. Observing them reveals the delicate balance of attraction and motion that governs the universe, a balance that holds even the smallest star systems within its quiet design. Together, they orbit a common gravitational center. The galaxies of the local group do not drift randomly through the void. They orbit a shared gravitational center, a point defined by the combined mass of all its members. Neither the Milky Way nor Andromeda sits precisely at that point, yet each moves around it in a vast and measured path. Their smaller companions follow, weaving through an invisible gravitational pattern that unites them all. This shared motion reveals the deep harmony that connects galaxies across space. Every orbit, no matter how long, is a response to the same fundamental pull, the same cosmic law that binds planets to stars and stars to galaxies. To picture this system is to imagine a slow, celestial dance, each galaxy tracing its own steps, yet all turning together around a center that exists only as balance, symmetry, and the quiet will of gravity. The local group itself drifts toward an even larger cluster. Even the local group is not still. It moves slowly through the universe, drawn toward a greater gathering of galaxies known as the Virgo cluster. This motion, imperceptible to the senses yet measured by instruments, is part of the vast flow of matter across the cosmos. Everything drifts towards something else, guided by gravity over unimaginable scales. The local group's journey toward Virgo will take billions of years, a slow pilgrimage across the great cosmic web that binds galaxies into larger and larger structures. Though the distances are vast, the forces involved are subtle and persistent, shaping the universe with quiet determination. Our entire galactic neighborhood is part of this movement, carried along like a leaf upon an invisible current. Through Andromeda, we see that nothing in creation stands alone. Every star, every galaxy, every cluster moves in endless relation to the whole. Beyond that lies the Virgo supercluster, home to thousands of galaxies. Far beyond the local group stretches the Virgo supercluster, a vast and intricate structure containing thousands of galaxies. It spans more than 100 million light-years, forming one of the great filaments of the cosmic web. Within it, clusters and groups like our own gather into immense patterns that extend as far as observation allows. The Virgo cluster lies near its center, glowing with the combined light of countless suns. Our local group drifts on its edge, slowly drawn inward by gravity's pull. This supercluster is not an isolated island, but part of an even greater network that links all matter in the universe. Every galaxy, every cluster, every particle participates in this grand design. To contemplate the Virgo supercluster is to face the immensity of existence itself, where even galaxies appear as small points within the boundless depth of cosmic space. Andromeda and the Milky Way are its brightest members nearby. Within the local group, two galaxies shine above all others, the Milky Way and Andromeda. Each contains hundreds of billions of stars and glows with the soft collective light of creation. From Andromeda's perspective, the Milky Way would appear much as Andromeda does to us, a vast spiral of starlight surrounded by faint companions. The two galaxies are bound by mutual gravity, slowly drawing closer across the void. Their shared brightness illuminates our region of the universe, serving as beacons for distant observers who might look our way. They are the twin anchors of the local group, balancing its motion and defining its structure. Together, they embody both symmetry and inevitability, for their approach will one day unite them into one. In their light, the universe shows how beauty and motion are intertwined, shining together across the ages of time. Studying Andromeda helps us understand galaxy evolution. Andromeda is close enough for astronomers to study in remarkable detail, allowing them to trace the full story of a galaxy's life. Its stars reveal clues about how it formed, how it has changed, and how galaxies across the universe grow and evolve. By observing its spiral structure, halo, and star-forming regions, scientists can compare its history with that of the Milky Way. Every discovery made in Andromeda reflects something about ourselves, showing how galaxies recycle their material through generations of stars. It provides a glimpse of what has been and what will be, a living example of cosmic evolution unfolding before our eyes. In its light, we see patterns that apply everywhere, from the smallest dwarf galaxy to the grandest cluster. Studying Andromeda is more than observation. It is participation in a shared story written in the language of stars. It offers a glimpse into our own galaxy's distant future. The Andromeda galaxy is not just a neighbor, but a mirror, reflecting what lies ahead for the Milky Way. Over the next 4 billion years, gravity will pull the two galaxies together, drawing them into a slow and graceful merger. When that time comes, the night sky of any surviving world will blaze with light as the galaxies blend and reshape. Stars will not collide, for the spaces between them are vast, yet their orbits will shift to form new structures of beauty. The result will be a single massive elliptical galaxy that shines brighter than either of its predecessors. This is not a story of destruction, but of transformation, where two grand spirals unite to create something entirely new. In Andromeda's glow, we see our own destiny written across the heavens, a promise of change that is both gentle and eternal. Every telescope generation reveals new secrets in its glow. From the earliest refracting lenses to the most advanced space observatories, each generation of telescopes has brought Andromeda into clearer focus. What once appeared as a faint cloud of light now reveals intricate lanes of dust, swirls of gas, and clusters of stars numbering in the thousands. Observations in different wavelengths, including radio, infrared, ultraviolet and X-ray, uncover still more layers of structure and energy. Each advance deepens our understanding and expands our wonder. The more precisely we see, the more mystery we uncover, as if the galaxy unfolds with every gaze. Andromeda is a reminder that knowledge and curiosity are endless companions, that discovery is a journey without conclusion. As technology grows, so too does our connection to this neighboring galaxy, which continues to share its light and secrets with anyone willing to look into the stillness of the night sky. Even amateur astronomers can photograph it from their backyards. Despite its immense distance, the Andromeda galaxy is bright enough to be seen without a telescope under a dark sky. Through binoculars or a small camera, it appears as an elongated glow, its central bulge shining softly against the surrounding dark. Amateur astronomers around the world capture its image with simple equipment, layering long exposures to reveal its delicate spiral arms. Each photograph is a record of light that has traveled more than 2 million years to reach Earth. The experience connects skywatchers directly to the wider universe, reminding them that the cosmos is not unreachable, but quietly present above us all. Andromeda's accessibility makes it a symbol of wonder within reach, a bridge between curiosity and infinity. For those who look up, even from a quiet backyard, the galaxy becomes a companion in the stillness, whispering stories written in light. Its faint shimmer connects us to a vast cosmic story. When you look up and see the faint light of the Andromeda galaxy, you are seeing photons that began their journey before humans ever existed. That ancient light has traveled across the silent void for more than 2 million years, carrying with it the history of countless suns. Within that shimmer lies the memory of creation itself, the births and deaths of stars, the collisions of galaxies, the slow breathing of time. To see it is to remember that everything in existence is connected by light. The same atoms that shine within Andromeda's stars flow through our own bodies, recycled from the same universal source. Its glow is both distant and familiar, a reflection of our origins and our destiny. Each time its light touches Earth, it reminds us that we are part of a story far older and more enduring than life itself. Through Andromeda, we glimpse the endless unfolding of the universe itself. The Andromeda galaxy is not just a destination for the gaze of astronomers, but a symbol of the universe's continual becoming. Within its spiral arms, new stars ignite even as others fade away, and entire systems rise and dissolve in an endless cycle. Watching it is like watching the cosmos breathe. Each photon that reaches us carries the imprint of that unfolding story. In Andromeda, we see that the universe does not rest. It creates, transforms, and renews itself forever. Its light has traveled across time to tell us that existence itself is motion, that all things are connected through the flow of energy and gravity. To gaze upon Andromeda is to witness creation in progress, an unbroken story written across billions of years. It is both a reminder and a promise that the universe is still becoming, and that we are part of its quiet expansion. As the light of the Andromeda galaxy fades from our thoughts, let yourself drift with it into the quiet stillness of space. Imagine floating beyond the Milky Way, beyond the reach of any star, where only the soft glow of galaxies lights the darkness. There, everything moves in slow harmony. The stars are silent, yet their light hums faintly in your mind, a gentle reminder that even in vastness, there is peace. The universe does not hurry. It expands and changes, but always with patience. The galaxies turn with grace. Stars are born in calm clouds of gas, and time itself unfolds like a slow tide upon an infinite shore. You are part of that same rhythm, a moment within the long story of light. The atoms in your body once drifted through stars like those you have just imagined. Their energy burns now as warmth within you, a spark of the same ancient fire. Let your breath follow that cosmic rhythm. Let your thoughts settle into the silence between the stars. The universe asks nothing from you but rest. Its beauty is enough. Its motion continues whether your eyes are open or closed. Somewhere, the light of Andromeda is still crossing the distance toward us, shining with the same steady calm it has carried for millions of years. By the time it reaches our world, you will already be far away in dream, floating among the stars that shaped you, peaceful beneath the endless night. Good night.